Good morning, viewers. I'm teacher Betty Bosa, a chemistry teacher. Last time we looked at laboratory preparation of gases, where we looked at different methods of collecting gases or stages taking place when a gas is prepared in the laboratory. We looked at how hydrogen is prepared from an acid and a metal to generate a solid and hydrogen. Then we looked at oxygen. Oxygen was obtained from hydrogen peroxide and manganese oxide as a catalyst. Today we are going to look at how oxygen acts on metals and nonmetals. Oxygen combines vigorously with many metals and nonmetals to produce basic and acidic oxides, respectively. Let us begin with the sodium, how sodium reacts with oxygen. With the unique part with the group 1 members, like sodium, potassium, they are kept under oil. Why? Because they are more reactive. They react with the air to form oxides. So they are kept under oil. This is the sodium, which is a gray metal. So kindly observe the flame. Sodium burns with a yellow flame. And when the oxide is dissolved in water, let us see what it will produce. They always say metals form basic oxide. When it dissolved in water, they produce an alkaline solution. How can we confirm an alkaline solution? We are going to add blue and red litmus paper in this solution and see. This is the blue litmus paper and this is the red. So when we put the blue litmus paper in the solution we made from the oxide of sodium, the blue litmus paper remains blue. But when you put the red litmus paper in the solution, the red litmus paper turns to blue. Therefore, metal oxide, when dissolved in water, they produce an alkaline solution which turn red litmus paper blue. Therefore, sodium burns in oxygen to produce a basic oxide, which when it dissolved in water produces an alkaline solution that turn red litmus paper blue. Generally, all metals, metal oxide when it dissolved in water produces an alkaline solution. So as you have seen in the experiment, sodium burns with a bright yellow flame and forms a yellowish solid. How do we write the equation? Sodium plus oxygen to give us sodium peroxide, which is the yellowish solid. When the peroxide is dissolved in water, it produces sodium hydroxide and oxygen. Usually this reaction leads to the formation of oxygen. Let's look at magnesium. We are going to use the magnesium ribbon to see how oxygen reacts with magnesium. So magnesium burns with a bright light flame, leaving a white ash. So let us now look at our observation. What have you observed? Magnesium burns in oxygen with a bright light and forms a white ash. So the equation is magnesium plus oxygen to produce magnesium oxide, and then magnesium oxide plus water to give us magnesium hydroxide. We are going to look at copper. For those who don't know copper, copper is brown. Copper is brown. Let us see how it burns. Copper burns with a green flame. And then it turns from brown to black copper oxide. So our observations are copper burns with a green flame, forming a black solid. So copper plus oxygen to produce copper oxide. The brown copper turns to black. For zinc metal, we are going to use zinc carbonate to get the clear observation. So zinc turns to yellow when hot. On cooling, it turns white. Now let us summarize our observation. Zinc on burning decomposes to a yellow solid when hot and turns white on cooling. Therefore, zinc plus oxygen is equal to zinc oxide. Iron filings burns with a shower of bright sparks and forms a black solid. Let us have a conclusion of our observation. Iron filings burns with a shower of bright sparks and forms a black solid insoluble in water. So iron plus oxygen is equal to tri-iron tetraoxide. We are now going to look at calcium. It burns with a red flame, leaving a white solid. Let us have a summary of our experiment. Calcium burns with bright red flame and forms a white solid. So calcium plus oxygen is equal to calcium oxide. And when the oxide is dissolved in water, it produces an alkaline solution, which is lime water, calcium hydroxide. Having looked at the metals, let us look at non-metals. We are going to look at sulphur. Sulphur is a yellow solid. Let us see what happens when it is burnt in oxygen. When sulphur is burnt in oxygen, it melts into an amber liquid. This is an amber liquid, then burns with a purple flame. When sulphur burns in oxygen, it burns with a blue flame, and when the oxide is dissolved in water, it will produce an acidic oxide. Let us test the acid formed with litmus paper. There is no action on red litmus paper. Let us see the blue litmus. The blue litmus paper turns to red. Therefore, non-metals burn in oxygen to produce acidic oxides, and when these are dissolved in water, they produce an acidic solution which turn blue litmus paper red. Let us summarize our observation. Sulphur burns in oxygen with a bright blue flame. So sulphur plus oxygen is equal to sulfur dioxide, and sulfur dioxide plus water is equal to the sulfurous acid, or produces sulfurous acid, and that is the acid that turned blue litmus paper red, as observed in the experiment. We are going to look at carbon. Carbon is charcoal. Burns with bright sparks and then produces an orange flame. So in conclusion, let us conclude our observation. Carbon burns with an orange flame and makes bright sparks. So carbon burns in oxygen to produce carbon dioxide, and then carbon dioxide plus water is equal to carbonic acid. Basing on all those observations we have seen when metals react with oxygen and also non-metals, let us look at the different types of oxides. We have basic oxides. These are the oxides which dissolve in an acid to produce a salt and water. And when those oxides are dissolved in water, they produce an alkaline solution, as it was seen with the sodium metal. Then we have another type of oxide, is an acidic oxide. Acidic oxides, those are the oxides which are produced by non-metals, as it has been seen with the sulfur. Sulfur is a non-metal, and when they dissolve in water, they produce an acid which turned blue litmus paper red. We have neutral oxides. Those neutral oxides have got, they cannot either show acidic nor basic properties. They are just neutral, and these ones, examples we can give are carbon monoxide. Another example of oxides are amphoteric oxides. These ones have got both acidic and basic properties or characters. Examples are aluminium 3 oxide and zinc oxide. We are going to look at a few activities of action of oxygen on metals. You remember we looked at different colors, what happens when metals react with oxygen. For copper, when copper was burnt in air or in oxygen, it burnt with a green flame. Remember sulphur? Sulphur also burnt with a blue flame. Sodium burnt with a yellow flame. And the oxide of sodium, when it was dissolved in water, the resultant solution turned red litmus paper blue, meaning that most of the metals, when burnt in oxygen, they produce basic oxide. For non-metals like sulphur, which burnt with a blue flame, its oxide, when it dissolved in water, the solution it turned blue litmus paper red, meaning that most of the non-metals, when burnt in oxygen, their oxides produce an acidic solution when it dissolved in water. Let us now today look at a few activities concerning the action of oxygen on metals and non-metals. The first activity is obtained from 1987, number 31, paper 1. Metal M was dissolved in nitric acid and the solution evaporated to dryness and then heated strongly until no further change. The residue was yellow when hot and white on cooling. And I think remember that metal which turned yellow when hot and white on cooling. The answer is A. Example 2 is from 88, number 3, paper 1. A compound Z, when strongly heated, leaves a residue which is yellow when hot and white when cold. Z contains, we are now given the metals in form of ions. We are given A as lead ions, B as copper 2 ions, C zinc ions, and D iron 2 ions. Our answer is C. The answer is C, zinc ions, because zinc oxide is yellow when hot and white on cooling. The next example is from 1993, paper 1, number 40. To the ashes obtained from combustion of magnesium in air, water was added and the mixture warmed. The products are or is, so when we burn magnesium in air, we get a white ash. That white ash is a composition of magnesium oxide and magnesium nitride. So when we dissolve them in water, we obtain ammonia and magnesium hydroxide. So our answer is 2 and 4, which is a C. Another example is from 1998, number 13, paper 1. Which one of the following is not an acidic oxide? Remember we said acidic oxides are oxides of non-metal. Incidentally, whatever we are given here are all non-metals. Carbon, sulfur, phosphorus, they are all non-metals. But I gave you the different types of oxides. I gave you the acidic oxides, of which I highlighted some examples, and the neutral oxides. The neutral oxides, the examples were water and carbon monoxide. So when we go back to our question, which one of the following is not an acidic oxide? Automatically the answer is B, carbon monoxide. Now let us look at 1994, number 27, paper 1. An element burns readily in oxygen to form a solid. The solid dissolves in water, producing an alkaline solution, and a gas that relights a glowing sprint. The element is, so you remember the gas that relights the glowing sprint, the gas was oxygen. We are given A, sulfur, B, sodium, C, magnesium, and D, phosphorus. The best answer is B. When we burnt sodium in air, it burnt with a yellow flame and produced a gray solid. That solid was sodium peroxide, which dissolved in water to produce sodium hydroxide and oxygen. Sodium hydroxide solution turned red litmus paper blue, and the oxygen will relight a glowing sprint. So the best answer is B. What happens is this: sodium solid plus oxygen gas to give us sodium peroxide, which is a gray solid. We balance the equation. So when this solid was dissolved in water, we get sodium hydroxide aqueous plus oxygen gas. So this oxygen gas is the one which relights a glowing sprint. This solution, it turns red litmus paper blue. How will we balance this equation? We introduce a 2 in front of sodium, and this will be 2 times 2, 4 sodiums. We bring a 4 here to balance the sodium. Let us look at hydrogen. Hydrogen, 4 times 1 is a 4, and I have a 2, so I introduce a 2. Will the oxygen balance? Let us see. 2 times 2 is 4, plus 2, which is 6. 4 times 1 is 4, plus 2 is 6. So the equation is balanced. Another example is from 1999, number 13, paper 2. Part A, draw a labeled diagram to show how a sample of oxygen can be prepared in the laboratory from hydrogen peroxide. I think you remember the previous experiments we carried out. You can be able to draw that apparatus, but to remind you, in the laboratory preparation of oxygen will involve only 2 stages, the production stage and the collection stage. So here we need a gas jar, which will be used to collect the gas. We have hydrogen peroxide, which is one of the reactants, a separating funnel, a delivery tube, conical flask, manganese 4 oxide or manganese dioxide, a beehive which holds the gas jar, a trough with water, and then a stand. The procedure is as follows. Put manganese 4 oxide into the conical flask. You slide, you do not drop. You connect a separating funnel fixed in a cork and a delivery tube. You arrange the apparatus as follows. This is a beehive. You place a gas jar with water on top of a beehive. You pour hydrogen peroxide into a separating funnel and open the tap. How do you test for the gas? We insert a glowing sprint. A glowing sprint is the one without a flame. This is a burning sprint. The glowing sprint is without a flame. So the glowing sprint is relighted. So kindly practice to perfect. Write ionic equation for the reaction that took place. Hydrogen peroxide minus 2 electrons to give us 2 hydrogen ions plus oxygen gas. So that is the ionic equation. State and explain what happens when each of the following substances are lowered in a gas jar of oxygen and water is added to the product. Burning sodium. I think you are recalling the color of burning sodium. So when we insert the burning sodium into a jar full of oxygen, it will continue to burn with a bright yellow flame. And when the solid is dissolved in water, it will produce an alkaline solution. So what will you write? You will say, burning sodium continues to burn in a jar full of oxygen, and the solid, when dissolved in water, it will produce an alkaline solution. Roman number 2, ignited magnesium. Ignited magnesium will continue to burn with a bright light, giving or leaving a white ash, and when the white ash is dissolved in water, it produces an alkaline solution of magnesium hydroxide. Roman number 3, iron. Iron continues to grow red hot, leaving a black solid, but when the solid is dissolved in water, it does not react with water. Part C, name one natural process in which oxygen is obtained. Mainly we obtain oxygen from photosynthesis. Part D, state two uses of oxygen in the society. Oxygen is used for respiration and burning. 2002, number 15, paper 1. Sodium burns in excess air, forming A, sodium oxide, B, sodium peroxide, C, sodium hydroxide, D, sodium hydride. So sodium plus oxygen to give us, we said it gives us sodium peroxide. Our answer is B. 2003, paper 1, number 1. Which one of the following gases dissolve in water to form an acidic solution? A, nitrogen, B, ethene, C, nitrogen monoxide, D, carbon dioxide. So an acidic solution must come from an acidic gas. So and this is carbon dioxide. Another question is number 2, paper 1, 2003. Which one of the following is observed when magnesium burns in air? A bright flame, B, a white powder, C, brown specks, D, molten beads. We observe a bright flame. And the answer is A. Another example is from 2005, paper 1, number 30. The oxide that dissolves more readily in water is A, which is sodium oxide, B, calcium oxide, C, lead oxide, D, copper 2 oxide. The answer is A, which is sodium oxide. You can wonder why. Oxides of group 1 element are very soluble in water, then oxides of other group elements are less, some do not even dissolve. Another example is from 2006, number 18, paper 1. Which one of the following substances forms an oxide which when dissolved in water turns red litmus paper blue? Remember which oxide when dissolved in water produced an alkaline solution which turned red litmus paper blue? Let us see the alternatives. A, carbon, B, phosphorus, C, sulphur, D, sodium. So when you look at A, B, and C, those are nonmetals. And we said nonmetals form acidic oxide. And our last answer is sodium, which is a metal. Metal, when burnt in oxygen, they produce basic oxide. So the right alternative is B. Another example is from 2015, number 6, paper 1. Which one of the following pairs of substances will react to form oxygen? A, sodium chloride and concentrated sulfuric acid. B, calcium carbonate and dilute hydrochloric acid. C. Potassium manganate 7 and concentrated hydrochloric acid. D. Sodium peroxide and water. Our alternative is D. Another example is from 2006, number 10, paper 1. Which one of the following metals will react with oxygen to form an amphoteric oxide? What are amphoteric oxides? These are the oxides which show both acidic and basic properties. So they react with an acid to produce a solid and water. They also react with a base to produce a solid and water. We are given A, zinc, B, iron, C, copper, D, magnesium. The answer is zinc. Zinc will form zinc oxide, which is an amphoteric oxide. Another oxide or another element which will produce an amphoteric oxide is aluminium. Aluminium will form aluminium 3 oxide. And the last example is, which one of the following elements is kept under oil? A, calcium, B, magnesium, C, sodium, and D, copper. We said in our experiment, the answer was sodium, which is kept under oil. All group 1 members are kept under oil because they are more reactive, or they react with air to produce oxides.
Tuzina muziki twebaze Katonda kubanga yagaba obulamu nafa yatuwa essuubi. Tuzina muziki twebaze Katonda kubanga yagaba obulamu nafa yatuwa essuubi. Mukama bwakuwa obulamu naffe tumulaga amasanyu. Tukoye mukaba nnyo mukolimo olituusawa. Bajjajja baatusinga nnyo bazinanga kimbeewo. Abedda bazinanga nnyo bazinanga zibbampu. Bayaye baatulyawo mirimu gy'abakomboozi. Ebyedda babikyusaamu buli kalungi kamufere. Naye tuzina omuziki twebaze Katonda kubanga yagaba obulamu naffe yatuwa essuubi. Wasaka nkuba amazina Nadia kankuba amazina Wanda bonyoma okuzina nsobola kuzina kuyamba nnyo tubeera mu exercise. Okuzina kuyamba nnyo kutta ne stress. Bajjajja bazinanga nnyo okununula ebyabo. Naffe twagala obwongo tulwanyisa obwavu era tufune obumu. Sitani mukambwe kabye yatukabya nnyo Muteesa yaddawo. Mwanga yali mukambwe nnyo Muteesa yaddawo. Tuwagira abazinyi tuzanyise ebiwato. Wala muzanyise ebiwato kitiibwa kya Katonda. Waffe ku kyalo gye nzaalwa obubbi bususse nnyo. Ubuzi babutwala bukoko babutwala obuteba bubba. Tuli ku lwa Katonda tuzinenga kimbeewa okulwanyisa obubbi. Tuzinenga kimbeewa okununula eggwanga. Okolima kiyambani bukaba kiyambani. Wasaka nkuba amazina tulwanyise embeera ngambye kankuba amazina tulwanyise embeera tuzina omuziki twebaze Katonda kubanga yagaba obulamu nava yatuwa essuubi tuzina omuziki twebaze Katonda